All right, how y'all doing today? Excited? I know I am. Let's look at this lesson. Unit 6, Lesson 1, Organizing Data. Let's find other ways to show patterns. Here's a data table. Each row shows two measurements of a triangle. So remember, we have a triangle, right? And we know two of the sides. So I'm guessing we know the short side and the length of the perimeter. And they're asking us, what do you notice? What do you wonder? Well, I'm looking at this and I notice there's lots of triangles. But I'm wondering, why is the data not organized? You know what I mean, Jelly Bean? Look at this. The smallest short side is 0.25, but the longest is 6.5. Why isn't it like over here? I don't know. Moving on. Seeing the data. Here is a table of isosceles right triangle measurements from the warm-up and an empty table. So just to give you a heads up, isosceles means at least two of the sides are congruent. Right means it has a 90-degree angle. And triangle means it has three angles. So we're talking about a shape that looks like this, where we have a 90-degree angle. And these two sides, I call them X, are identical. Okay? They're asking us to organize the information, or sorry, how can you organize the measurements from the first table so that any patterns are easier to see? Oh, they want us to actually organize it. Big oof. Well, you know what? Let's start smallest big. Let's see who can do this faster, okay? Go ahead and you try organizing this data. Remember, if this is 0.25, you also write 1 right here, okay? Ready, set, go. Dun, 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 dun. 1, 2.5. Cross that out. 1.25, 1.25, 3.5, 1.5, 5, 7.5, 3, 9.5, 3.5, 12.5, 4, 14, and 6.5, 22. Bet. Who won? I did or you did? Oh yeah. Yep. You totally won. Yup. Psych. For each of the following lengths, estimate the perimeter of an isosceles right triangle whose short side have that length. Explain your reasoning for each triangle. Okay, so we have our list, by the way. Okay, it's organized. So if the length of a short side is 0.75, oh, notice how it's between the 0.5 and the 1. 0.75 is exactly between 0.5 and 1. So it makes me think the perimeter is going to be exactly between 2 and 2.5, which is 2.25 centimeters. Okay, length of short side is 5 centimeters. Once again, it's going to be somewhere right here. 5 is closer to 4 than it is to 6.5. So it should be closer to 14 than it is to 22. So I'm just going to say 18? 18 centimeters? I don't know. Your choice. I mean, you get to decide. And then length of 10. Oh, oof. So here you can definitely use your critical thinking skills. You can find a unit rate. There might be a unit rate involved here. Kind of looks like it, right? 0.25 times 4. 0.5 times 4. Oh, wait, you know what? It doesn't work because 1 times 4 is not 2.5. But hey, man, or sorry, hey, as long as it's above 22, I'm all up for it. Must be bigger than, what was it, 24? 22. Are you ready for more? Heck yeah! In addition to the graphic representation of data you have learned, there are others that make sense in other situations. Examine the maps showing the results of the elections. Ooh! For a United States president for 2012 and 2016. And red are the states where a majority of electoral votes, you should know that, were casted for the, oh, my bad, Republican nominee. And blue are the states where a majority of the electorate votes were casted, oh pues, for the Democratic, let me just, thought, okay, whatever, for the Democrat nominee. Damn, you see all that red? Psh. What information can you see in these maps that would be more difficult to see in a bar graph showing the number of electoral votes for the two main candidates? How about how many actual votes were casted? For example, this makes us think, what is this, Montana? This makes us think that in Montana, I mean, it's true, more people voted red than blue, but I mean, if you look at how many red states there are, this makes us think that the Republican won, but we know that didn't win. Thanks, Obama. Why are these representations appropriate for the data that is shown below? Well, if we look at what it's showing, examine the map showing the results. These are just results. Table and their scatter plots. Oh, focus area time. Here are 4 scatter plots. Get it? Scatter, like it's random. Your teacher will give you 4 tables of data. Am I? Oops. Go ahead and just do this. Whee! And that's actually it. But let's just review the summary. This is something I really want y'all to be doing at the end of a lesson. Consider the data collected from pulling back a toy car and then letting go forwards. It's one of those little Hot Wheels, that's my car. You pull it back, and then it does, it goes that way. In the first table, the data may seem not to have an obvious pattern. Well, of course. The second table has the same data and shows that both values are increasing together. Well, that's nice. You see how unorganized it looks fugly? There's no pattern. But when you organize it, look, you can actually see a pattern. As the distance gets bigger, as you're pulling it back more, the little Hot Wheels is traveling even further. And look, it looks like there's a pattern. It almost looks linear. Sorry. Please say linear. It looks linear, positive, or negative. I'll leave that up to you. That's it. Thank you all for enjoying my company. I hope you have a wonderful, whatever the heck today is.